So far, you have learned the differences between cleaning, sanitizing, disinfecting, and sterilizing. So with this new knowledge, proper facility sanitation may actually seem easy. Just use the right type of products and procedures for the correct application. Herein lies the challenge with that one little word, use. Since most products are sold as concentrates, your employees must learn how to use them properly for the intended usage application, else risk a sanitation breakdown that results in disease outbreaks. And product labels definitely do not help them demystify the process, just the opposite. Product labels are confusing with all their tiny print, and the sheer process of diluting chemicals with water add more mystery than understanding. How do your employees know 100% that they are mixing solutions correctly? The short answer is, they don't. This is what we call dilution confusion. It is difficult for the non-expert to fully appreciate the different dilutions required for cleaning versus sanitizing versus disinfecting, or the dilution requirements for non-food contact surfaces versus food contact surfaces, and the inherent limitations of chemicals themselves. Managers, for example, may be easily coerced into believing they are disinfecting and saving money along the way, when in fact, they have diluted a product only to a cleaning or sanitizing level, thus creating a recipe for disaster when a disinfectant is what's really required. Our conclusion: proper sanitation is actually complicated, and there are no single product solutions that will do everything. Instead, you must develop sanitation programs that combine appropriate products with appropriate usage applications for the exact task at hand. But before we introduce the details of sanitation programs, there are two fields of physical chemistry that are critical for your sanitation success: understanding the pH scale and the properties of hard water. The pH scale runs from 0 to 14, with 6 to 8 being the desired neutral points. 7, for example, is very close to the pH of our blood or water. Thus, chemicals registering between 6 and 8 are the goal for using the safest compounds available. When you start moving outside of pH neutral towards 0, you start moving closer to the acids. Acids are very corrosive compounds analogous to battery acid. Many popular solvents sold and used in your industry are highly acidic and will ruin facility infrastructure over time and literally poison your people. Move to the other end of the scale, toward 14, are bases or alkaline substances, which are even more corrosive and disruptive than acids. And again, many products sold in your world have pH values near 14. As for hard water, many disinfectants claim efficacy in hard water, but as stated before, it's time to read the labels. Many are only labeled effective in up to 200 parts per million of hard water. Unfortunately, that does not represent the American water supply. As you see in this map, most of the U.S. has hard to very hard water. That makes those products incompatible for the sanitizing and disinfecting needs of most locations across the USA. Thus, it is imperative to find a solution that maintains efficacy in up to 400 parts per million, which protects the entire U.S. by a factor of 2. In conclusion, it is important to clearly understand the pH scale and hard water efficacy and how it can affect your staff, customers, and building. Your goal being to use products that are pH neutral, as well as being effective in up to 400 parts per million of hard water. We cannot overstate the importance of reading and understanding labels and safety data sheets when evaluating products to use. Or you can let Green Planet Scientific do the heavy lifting and create your own safe, infallible, and effective customized sanitation programs. In our next video, you will discover all the scientific benefits of such a program, designed specifically for your unique situation.